Next, Dr. Fatih Sütçü from the Earthquake Engineering and Disaster Management Institute of Istanbul Technical University and Dr. Cem Yenidoğan from Civil Engineering Department of Yıldız Technical University will talk about their observations regarding the building damage.
Yes, thank you very much, Dr. Erberik. I will just shortly summarize our observations in the disaster area. As Istanbul Technical University team, we have been in Adıyaman and Maraş area. So most of the things I will be showing will be from those two areas. Although in the beginning, I would like to shortly talk about the devastating events in terms of spectrums. So this is Turkish seismic hazard map, and in the red areas, we are expecting higher peak ground accelerations, as you may understand from the figure, and these are the observed ground motions in the first couple days. And let's take a closer look, and maybe I can show you which earthquake corresponds to what kind of spectral values. Here, this one is from Kahramanmaraş, Pazarcık area. On the top, you can see the wave, the recorded wave. And here, let's take a look at the spectrum. Here you can see the spectrum. I mean, the black lines here are the design spectrums. In the Turkish seismic code, the design spectra change depending on the soil type. But anyway, the maximum points are around 1 and a little bit over 1G. But the observed spectrum values the acceleration values are a little bit higher than almost 5G in the short period area. Similar observations can be made for peak ground velocities or the velocity spectrum. So you can see that the velocities are over 200 centimeters per second, which is quite large. And let's take a look at another area. And here, this area is Gaziantep. It's a little bit further from the highly affected areas. And we can also see that from the spectrum, the design spectrum and the observed spectrum is quite close in terms of acceleration. But here you can see that in a very short period range, like 0.1 second or something like that, there is a peak a little bit higher than 2.5 G, which may explain the collapse of the castle in Gaziantep, because as you know, these kind of stone masonry structures, which is settling on a big rock, has very small vibration periods, which can resonate with this 0.1 second peak. Similarly, in this area, we have quite high velocity values, especially in the short and middle periods or medium periods, let's say. Okay, let's take a look at one of the most affected areas, which is Hatay. In Hatay area, we see something similar to Maraş, especially in the short period range, let's say 0.3 to 0.5, which most of the short buildings are in between this range, as you know, and we see here more than 4G accelerations. And similarly, very high velocities here. And displacements are maybe we don't need to discuss about the displacements, but the accelerations and the velocities are obviously very devastating. And this study is made by Professor Çelik and his colleagues from Technical University Department of Architecture. Okay, as AFAD, the emergency agency has announced there are more than 11,000 collapsed buildings. But as you know, together with the collapsed buildings, we should also consider the heavily damaged buildings together, because all these buildings have to be reconstructed. And when we put them together, I mean the heavily damaged buildings plus the collapsed buildings, here we have a map. And especially in this Hatay area, as you can see, there are more than 10,000 heavily damaged and collapsed buildings. So this map actually shows the most affected areas. And here we have Kahramanmaraş, and here we have Adıyaman. The central parts of Adıyaman and some parts of Malatya have been hit most heavily by this earthquake in terms of damaged and collapsed buildings. I will very shortly talk about what kind of damages were observed. And this first one is considered as minimal damage, where the structural system is intact, but the partition walls or some other secondary members are damaged. Of course, there were some cases where the partition walls or the infill walls were just slightly separated from the structural system, which is acceptable. But here there are some cases where the facade of the structure or the internal walls are completely collapsed. This is considered as minimal damage, but actually these buildings cannot be used anymore. I mean, the structures survived, but I'm not sure if these buildings can be considered as homes anymore. These ones are middle to heavy damages. Of course, these mostly like this tilted building, it's obviously a heavy damage. This one cannot be used anymore. There's lots of residual deformations and lots of heavy damage in structural members. Here we can see a soft story which completely collapsed. And here there's an interesting one, like these three buildings were adjacent to each other. So there were no gaps in between. And there was pounding and or hammering between these structures. At the same time, the first two floors of this middle building have completely collapsed because of the soft story mechanism. And these are the completely collapsed buildings. In some literature, this is called a pancake type collapse. Shortly, I will just talk about the reasons of these damages. This particular one, I have taken this photo, it's interesting. On the right side, you can see, okay, in the first two floors, here there are some shops, okay? And this is the first building, here is the second building. This is the third building still under construction. And we can see why these kind of damages or collapses occurred. Here, for example, you can see that these columns are obviously weaker than the beams they are connected to. So these do not follow the strong column, weak beam concept. And here, these two buildings, you can see, they are both made by the same company, but one of them completely collapsed and hit on this one. And here there is a huge impact, as you can see. And let's take a zoom. Here you can see because of the collision or because of the hit, the corner column is completely gone. But the building is still standing. Actually, this shows that our buildings are quite strong when they are properly made, but it's difficult to explain how a twin building made by the same contractor behaves so much differently from each other. And this is not related to the soil. They are just next to each other in this case. In Maraş area, we have visited lots of industrial areas, and the biggest problem with the industrial areas are the connections. Here you can see some precast column here, and there's the precast beam here, and the connection is very poor. This is a good example, actually. It just dislocated a little bit. There are some pins here, and but in many cases, this very heavy precast beam has been completely collapsed or fell over the machinery or the equipment inside the building. And these kind of buildings can easily be retrofitted by using conventional methods, and their performance can be improved by using some dampers, because as you see, these kind of joints can benefit from some energy dissipating devices. This has already been explained by my colleagues, but we have seen some liquefaction in the rural area, and the same liquefaction caused lots of collapse or tilting, as shown in these examples. And here you can see the building is completely intact. The windows are just in its place. Nothing is broken, but the building has completely collapsed or tilted, only stopped by the shorter building on the behind, and this building just crashed on it. And here are some examples why these kind of pancake type of collapses happen. Let's take a closer look. There are several reasons. First, these are round bars. You see, they are not deformed bars, and the stirrups are very weak, and the number is insufficient, and there are no hooks. The concrete condition is not good. The amount of rebars are not good. The rebar detailing is not good. And again, here, the columns are, in most cases, weaker than the beams that they are connected to. Thank you for listening to me, and I hope to see you in the conference in November in Antalya, Turkey. Thanks.
My name is Cem Yenidoğan, and I will try to give you some brief information about the reconnaissance reports and where we have visited during the reconnaissance trip. Generally, we have visited several places in the earthquake-affected region. Our first visit was just in 2 days after the earthquake when we heard about it. And generally, the main issue when you were just trying to visit the area was the disrupted roads. So we have to use some off-road type of cars to pass these type of some issues that we on the site. And when we have some earthquake records, we wanted to focus on where the damage is heavily focused. In Hatay, Kahramanmaraş were the main interest for us, but also we want to see the Adana region, which was slightly affected. So this is the seismic hazard map, as Dr. Sütçü just mentioned, and the 11 provinces were affected from these earthquakes. And when we make a classification, we can say that Hatay, Gaziantep, and Kahramanmaraş are the main provinces that are heavily damaged. And if we classify moderately damaged provinces, we can say that Malatya and Adıyaman. But for the low damaged provinces, for example, Adana, Diyarbakır, Osmaniye, Şanlıurfa, Elazığ, and Kilis. Interestingly, in Adana, for example, we have total collapses. 11 buildings were totally collapsed, and some of those buildings were having 16-story, 14-story, and it was surprising for so many people. And some of those buildings were constructed in 2005. In February 16, this data was shared by the Ministry of Urban Environment and the Climate Change. And as you can see, the total number of damages are significant when you just consider the moderate and the heavily damaged. We were not expecting such kind of an extensive damage in that region. I would like to show you some damage photos, some damage survey photos. Of course, I will not get into very detailed information about the technical aspects, but later during the conferences, we will get into detail. This is the Gaziantep castle, which was damaged during the earthquake. Also in Gaziantep region, we have the Nurda region. We have 2 stories, also some multi-story buildings up to 8 or 10 stories. And the most common damage that we were just observing was the soft story related damages. Also, in the first 2-3 days, we have seen this type of scenes a lot, the pancake collapse, but also the soft story collapses really so common and widespread, as you can see in these photos. In addition, I would like to show that the unreinforced masonry infill walls, they have created a lot of damages, not just only to the structural system, but also the cars. Most of them are smashed due to these unreinforced infill masonry walls. So there are some lessons that we can learn, but the same type of damages were seen in all earthquakes that we have experienced since 1999 Kocaeli earthquake. Also, temples. I mean, some of the mosques, as you can see, there are some slender structures such as the minarets, and they were just totally collapsed. In Hatay region, we have heavy damages, especially this Hatay region was the most heavily damaged region due to many reasons. Especially, we cannot just attribute this damage only to the soil or only to the directivity related situations or some source characteristics or the recourse. So many things were gathered together, and we have to just look at these things in a very broad perspective. Kahramanmaraş, when we were just making our first visit, we went to the area at nighttime, and it was really like a nightmare, I should say that, and it was very risky. The roads were really narrow, and most of the buildings and the aftershocks were creating really huge problems. Most of the buildings were heavily damaged. But also in Kahramanmaraş, there was some kind of a very interesting structure that in all broadcasts was just declared that this building, which is belonging to the civil engineering chambers. So nothing was special about this building. We went to there and we just made some surveys about it. Nothing so special. They just only followed the building code regulations, and the buildings just surrounding this 3-story building were damaged. And when we made some interviews with the locals, they just said that the old city has slight damages when you just compare this region. So there was a big distinction between the newly constructed area as well as the old settlement of the Kahramanmaraş. Also, there were some surface ruptures we just found out in several areas, but I will not get into detail because the geotechnical aspects were already discussed. But when we just check out the structures, most of the structures were not have any engineering treatment. Generally, they have done by the people who lives in the village. And when you just compare the seismic detailing, and so many things were deficient in those structures. Apart from that, we also made some surveys about the industrial structures. This is our second visit to the earthquake affected region. And in that area, we've just found out that in the industrial zone, there were some steel structures. Most of them were not really affected, only one steel structure, but it was related to the fire-related issue. And they all performed quite well, but for example, when you just check out the precast structures, as Dr. Sütçü just mentioned, the connection details were just poor. In addition, there was some loss of functionality and they could not make the factories work in a proper sense. Also, the racks, as you can see, they created huge amount of losses. And on the right side in here, you can see that the retrofitted structure, which was also had some moderate damages. In addition, we wanted to check out with the Japanese team, with the AIJ team. We were on site together with the AIJ team, and our main task was to check out the hospital performance, hospital building performances. As you can see, most of the hospitals had really good performance, except the non-structural components. This is a typical damage that we have just seen as a result of the suspended ceilings, as well as some of the sprinklers had some issues. But when we made a comparison with the seismically isolated hospital buildings, we see that they have performed quite well, and Dr. Şadan will make the presentation about the seismic isolation. Therefore, I will not get into detail about it. But what we have seen, there was a success story of the seismically isolated structures. Also, even conventional, the fixed base structures as a structural system performed quite well. So the main issue was related with the non-structural component, and which made some of the hospital buildings to lose functionality, or they made a decision to evacuate the buildings. So there were some concluding remarks. I would like to say that the main issue related with building performances are the low quality concrete production prior to the use of the ready-mix concrete. And additionally, there were widespread reinforcement detailing deficiencies, bone slip effects due to use of plain steel reinforcing bars, inadequate lap splices at the column and wall bases, inadequate spacing of the transverse reinforcements, lack of cross ties, and 135-degree hooked up stirrups even in newly constructed damaged buildings, and use of smaller diameter reinforcing bars that were creating some constructive detailing issues to place the concrete, buckling of the longitudinal bars. In addition, I just expressed that the non-structural component and non-structural systems created problems, suspended floor systems, as well as the usage of the ground floors, such as the office buildings or just as shops. They just created a lot of problems, and such kind of slender elements had some non-structural components, and we have to think about how to make such kind of damages lower by creating some special connection details for such systems. I would like to express my gratitude to YTU for their support, taking rapid actions to send academics and the researchers to the field. Also, the support of AIJ for the seismic isolation system assessment and the steel damage assessments. These are greatly acknowledged. Thank you very much, and I hope to share more information because we have more than 5,000 photos as well as some analysis that we can share during the conference. Thank you very much.
Okay, I would like to thank Dr. Sütçü and Dr. Yenidoğan for their valuable contributions regarding the building damage.